In section 7.6, we're concerned when we have a small sample whether or not, and this is for quantitative variables only, so for quantitative variables, we're very interested in knowing whether or not we can use the central limit theorem. So this will only apply to quantitative variables because qualitative variables we already know that n times p has to be greater than 10 and n times 1 minus p has to be greater than 10 in order to use the central limit theorem. So we have four ways to look at normality. One, we'll use dot plots to assess normality. We'll use box plots to assess normality. We can use the normal quantile plots to assess normality. And finally, the one that I like to use is XL skewness measure. So we'll go through each of these in this section. Objective 1. Use dot plots to assess normality. Many statistical procedures require that we draw a sample from a population whose distribution is approximately normal. Often, we don't know whether the population is approximately normal when we draw the sample, so the only way we have to assess whether the population is approximately normal is to examine the sample. There are three important ideas to remember when assessing normality. We're not trying to determine whether the population is exactly normal. Assessing normality is more important for small samples than for larger samples. Hard and fast rules do not work well. So we will reject the assumption that a population is approximately normal if a sample has any of the following features. The sample contains an outlier. The sample exhibits a large degree of skewness. The sample has more than one distinct mode. If the sample has none of the preceding features, we will treat the population as being approximately normal. We often use plots to help assess normality. So in our first example, the accuracy of an oven thermostat is being tested. The oven is set to 360 degrees, and the temperature when the thermostat turns on, off, is recorded. A sample size of 7 yields the following results. Is it reasonable to treat this as a sample from an approximately normal population? Well, in this particular case, we look at the outliers on a number scale for the value x, and we don't see any major discrepancy in temperature in terms of outliers. So the plot does not exhibit a large degree of skewness. There's no evidence that the population has more than one mode. Therefore, we can treat this as a sample from an approximately normal population. At a recent health fair, several hundred people had their pulse rates measured. A simple random sample of 6 records was drawn, and the pulse rate in beats per minute were 68, 71, 79, 98, 67, and 75. Is it reasonable to treat this sample from an approximately normal population? Well, in using a dot plot, it is clear that the value 98 is somewhat away from the rest of the data set and may be considered an outlier. Therefore, we should not treat this sample from an approximately normal population. Objective 2. Using box plots to assess normality. When we have larger data sets than the ones we saw in the previous two examples, box plots are somewhat better to use in terms of finding skewness and outliers. In this example, an insurance adjuster obtains a sample of 20 estimates in hundreds of dollars for repairs to cars damaged in collisions. Following are the data, and you can see that they are here. There's a little bit bigger than what we have seen in the other two examples. Is it reasonable to treat as a sample from an approximately normal population? Well, in this particular case, the box plot reveals that there are no outliers. Although the median is not exactly halfway between the quartiles, the skewness is not great. Therefore, we may treat this sample from an approximately normal population. Here's another example. A recycler determines the amount of recycled newspaper in cubic feet collected each week. Following are the results for a sample of 18 weeks. Is it reasonable to treat this as a sample from an approximately normal population? A box plot reveals that the value 4334 is an outlier. In addition, the upper whisker is much longer than the lower one, which indicates fairly strong skewness. Therefore, we should not treat this sample from an approximately normal population. Objective 3. Use normal quantile plots to assess normality. Normal quantile plots are somewhat more complex than dot plots, histograms, stem leaves, and box plots. The following example illustrates how to construct a normal quantile plot. So a placement exam is given to each entering freshman at a large university. A simple random sample of 20 exam scores is drawn with the following results. Here they are. We construct a normal probability plot using technology. This distribution of exam scores is approximately normal, is the question. Well, when we use the quantile plot using our calculators, and this is one of the reasons why we're showing this, is that you can do this relatively easy on the calculator. The points on a quartile plot do not closely follow a straight line, so we don't believe that the data is approximately normal. So what we're looking at is a data set that follows closely linear from this particular plot. If it doesn't, then chances are probably pretty good that we do not have a normal distribution. So on using your TI-84, here is the procedure for quantile plots. The step for constructing the normal quantile plot on the TI-84 calculator are the following. Enter the data into L1. We did that. Press second Y equal to access Stat Plots menu and select Plot 1 by pressing 1. So select on and then the normal icon, the normal quantile plot icon is then selected. This information comes up. So for data lists, you select L1. For data access, you choose the X option. You press the zoom key and then option 9, zoom stats, and you get the quantile plot. So most of our data sets, we want a skewness measure. The skewness measure helps us determine normality of a data set. So with the skewness measure and the box plots primarily will be used to assess normality. Excel calculates a skewness measure for a data set under the descriptive statistics option. This measure determines the approximate normality of the data and is used to assess whether the central limit theorem may be used for a quantitative data set. If the skewness measure is between -1 and 1, the data is approximately normal. A placement exam is given to each entering freshman at a large university. A simple random sample of 20 exam scores is drawn with the following results. Same problem as before. Find the skewness for the data set. Is the distribution of exam scores approximately normal? Well, using Excel, we enter the data into a column in Excel. We move the cursor to the top of the Excel menu and choose Data. Select the data analysis from the data menu, which is on the far right hand side, and then choose, when the menu screen comes up, Descriptive Statistics. Select data in the column you entered and make sure the Summary Statistics is checked as on. For the previous example, the skewness measure is 1.76. So when we do the data analysis option, which we've used in class before, you will see a skewness measure. In this case, the data is not normal, it is skewed to the right. So in this section, you should know the conditions for rejecting the assumption that the population is approximately normal. You need to know how to use dot plots, which we'll use periodically, especially for small data sets. For the rest of the data sets, we will be using box plots to assess normality. Very seldom will we use the quantile plots, but it's available on your calculator, so we decided to show you. And finally, how to get a skewness measure from Excel. So we will be using this particular feature as well. Well, that concludes Chapter 7, and we will be now doing estimation in Chapter 8.